Hello, everyone, and thank you for joining us today. My name is Emily Zatar, and I'm with the International Sign Association. We are very pleased to welcome you to our webinar today, Beyond Sign at ISA Sign Expo, Adhesive Safety Considerations and Compliance. This is the second in a series of webinars that we are hosting to expand on some of our most popular sessions, our in-person sessions from the ISA Sign Expo. Before we get started, I have a few housekeeping items to cover. First, we have enabled the live transcription and captions. If you would like to use those, please click on the live transcript button at the bottom of your screen to turn on the closed captions. Secondly, we ask that you please submit your questions today through the Q&A option. That will help us keep track of the questions that come in and make sure that we answer them. You can use the chat to chat amongst yourselves, but we ask that all questions are submitted through the Q&A. Third, I would like to mention that this presentation is not legal advice or the final words on any topics raised today. So please review the information presented today with your internal or external counsel. And lastly, we will have a recording of today's session, as well as a copy of the presentation made available within a few days after the webinar wraps up. You will receive a follow-up email on how to access those materials. I will now pass it along to Brad Turpin Jr. with ISA.
Hey, everybody. I'm Brad Turpin Jr., Content Development Manager here at International Sign Association. Welcome to today's webinar, Adhesives in Sign Manufacturing. And as Emily said, it was inspired by the success of this course as well as others at our Expo education session. So we just wanted you all to know that we're continued our commitment to year-round learning and want to connect our Expo with all of our other education. So this session explores adhesives as an alternative to welding, soldering, or mechanical fastening. It's perfect for your manufacturing team. And I understand this is a very busy time of year, and most of them probably aren't on this webinar, but please share the recording with them. And as I've been talking with Andrew before, we actually have an online course on this very topic that's set to release here in early October as well. So we'll let you know when that's available. And so we're doing all this for you. So please spread the word to your team and your colleagues, and would like to get started. So now I'll turn it over to Andrew for you all to handle some brief introductions. Andrew.
Okay. Hey, welcome everyone. Thank you for taking the time to join us. Quick thank you to Brad and Emily and the entire ISA team. Really appreciate you guys having us on and all the efforts that you guys take to really support the industry and bring education to the industry. So thanks again. Again, I'm Andrew Morris. I'm President and CEO of Chemical Concepts, and I'll be joined today by PJ Hatchell on my team, also at Chemical Concepts, and Rod Flemming with IPS Corporation, IPS Adhesives. PJ and Rod, or PJ, why don't you go first? You want to do a brief introduction on yourself as well?
Yeah, sure. Hey, everybody. I'm PJ Hatchell. As Andrew said, I work alongside him here at Chemical Concepts. I manage our sales for the South Central U.S. I've been in the sign industry my whole life. I was born into it down here in Houston, Texas, and I love this industry. So I'm looking forward to diving into adhesives with everybody today.
Yeah. And Rod?
Hi, everybody. My name is Rod Flemming. I am the National Sales Manager for the Sign and Display platform for IPS Adhesives. We manufacture a number of structural adhesives as well as solvent cements for the fabrication of electrical signage. I've been with the company from 2013 in a variety of different commercial-facing roles. Very happy to be here today and walk you all through some of the compliance considerations with respect to using methylene chloride moving forward.
Yeah, so that's a great transition, Rod. Thanks, Rod. Thanks, PJ. Why are we here? Why are we talking about? Why am I here? Why am I talking to you guys? So I've been doing, for the better part of 15 years, I've been, consulting with sign shops on their bonding and assembly challenges, helping them put things together better, answering questions with regard to adhesives, troubleshooting applications, consulting on reducing, welding and mechanical fasteners in favor of adhesives. And Chemical Concepts has been doing this for over 60 years. And so we were approached by ISA. This is really the third instance in a series. We gave a series of talks at the last two ISA in Atlanta and Las Vegas, respectively, and wanted to just bring this content by popular demand. to a larger audience in terms of an online audience. We know there's many of you guys out there that are stuck in the shop. You've got a lot of work. You guys are busy. I'm walking around. I'm stopping in sign shops, and I'm hearing from many of you guys that are so slammed. So I know for every company that is able to make the trek to one of the ISA events, there's many more people out there that just can't get away for one reason or another. Or maybe your company is able to attend, but probably any given company can only spare one or two people, or maybe three or four for the larger organizations to get out of the shop. They need a certain core amount of people there getting the work out the door. And this talk is really geared towards the people in the shop, the people working with the products, the people that are hands-on, people that it's probably hardest, to get away. So I'm really excited to be here and present some of this content. We're here to really answer your questions. To me, adhesives are another tool in the toolbox, and you guys are craftspeople. At the end of the day, what is this all about? It's all about producing signage, producing great results for you guys to produce great results for your customers. And we think that, at least I think that in my experience, again, being in hundreds of sign shops all over the country, and the other thing is that we're really adhesive specialists that focus on not just sign shops, but in all industries where adhesives are used. And there's a lot of commonalities in manufacturing, whether you're building a sign, a truck, a piece of electronics, or a kitchen countertop. A lot of the assembly challenges are similar. So anyway, that kind of brings us to why we're here, and it's very timely. There's a lot of confusion in the industry. Adhesives are one of the least understood tools in the toolbox, to what I was saying earlier. So our goal is to kind of arm you, give you the information that you need to make informed choices and to produce work that's going to stand the test of time, look great, and make your customers happy. So that is basically our goal today. So I'll talk about the programming, as I mentioned, with the timeliness. As many of you know, and I think many of the people watching this today are very interested, there's these burning questions around the methylene chloride EPA ban that took place. I think it was finalized in April 2024, if I'm not mistaken on the timeline. And it is effective now, and it will be phased out really, unless you have a workplace chemical protection plan, at the end of January. I believe it's January 28th or 26th, 2025. There'll be more information on that. But we basically have this organized into three main sections. There's a kind of Adhesives 101, why adhesives, general information up front that I'll be covering. I'll pass it to PJ to kind of talk about some best practice information that's going to be really useful for you and all the people in the shop to make sure you're doing the 1, 2, or 3 simple things that are really going to make that difference between success and failure. And it's a lot of very simple things that's going to, if followed, get you guys out of a lot of hard situations or sticky situations, as the case may be. I know he's groaning already. And then Rod will end with heading up some information on that compliance information, the changes, the new products. So make sure you stick around to the end, because there's going to be, that's an area where we've had a big flurry of activities. So what are the main things, the takeaways for you? It's really identifying the main types of adhesives, a little bit about kind of, again, Adhesives 101, joint design, how to use adhesives, how to think about adhesive selection, surface preparation, best practices, troubleshooting, and then really understanding when to use what. And then lastly, again, that information on compliance and methylene chloride. So again, just to make this interactive, this is here to solve your problems, your challenges, your questions. We want this to be useful to you. I have this survey on the screen, and if you could fill it out this way. If you guys have your phone, everybody has their phones in their pockets. There's a QR code in the top corner. If you wouldn't mind scanning that, and it's going to take you through the prompts to basically answer this question, which is, how do adhesives fit into your shop? And where I'm going with this, and as I'm talking, you guys will be able to participate, and we should see this kind of update in real time. Hopefully it works, and feel free to. There we go. Cool. We'll be, if you have any issues using it, jump in the chat, and I think PJ and maybe Emily and Brad will be monitoring the chat as well, and we'll make sure that if we can't answer any of your questions in real time, we'll make sure they get answered eventually. So. This is going to kind of set the stage to what we're talking about, because I think people tend to fit in a couple of different buckets. As I go and visit sign shops, It's one of these things, right? We're adhesive power users. We're using adhesive every day. We glue everything all the way to the other end of the spectrum. Man, I don't trust adhesives. I weld everything. And there's no right or wrong answer. Again, it's just a tool in the toolbox. But it does help us kind of gear this presentation towards you and kind of, again, set that stage for why are we even talking about adhesives. So I'll just give you a couple more seconds for people to kind of get this going. I know you have to scan the QR code, but this is going to be interesting because I think if you looked at these numbers, and this is the third time I've done this, that I did this in the 2 live presentations, the same survey. And I think if you were to track these numbers across time over the last, say, 15, 20 years, you'd find that the results are very different, that adhesives have really become, and especially the bigger the group, the bigger the sample size, adhesives have really become a key part of the way signs are manufactured. So, all right, maybe a couple people are still doing this, but I think at this point we have a spread. This is kind of an interesting mix. So we have kind of almost a 50-50 split here. Adhesives are an essential tool in my shop, and I rarely or never use adhesives. So basically everybody on this call, there's a couple people that fit into that third category, and nobody has selected that they occasionally use adhesives. So this is a tale of two cities here, and hopefully by the end of this presentation, people in both camps will have walked away maybe learning something that they didn't know at the outset. So that takes us to this question: why adhesives? So as I mentioned, you guys are craftspeople. Adhesives is an important tool. If you're somebody that uses adhesives all the time, if you fit into that first camp, I want to make sure that you're armed with information to make better decisions, to make better choices, to think about how you're selecting adhesives, when you're selecting adhesives, and maybe there's applications at the end of this that you'll consider using an adhesive in an area where maybe you wouldn't have yesterday. And for those of you that fit into the other camp, I rarely or never use adhesives. I'm not really here to change anybody's mind. I'm just here to provide information and at least challenge you guys to think differently about how you assemble things. Because again, what is that goal? That goal is to help you guys build things better, faster, and maybe cheaper. I don't really want to emphasize the cheaper part, but being competitive and fitting into this competitive landscape is important. And so if there's a more efficient way of doing things, that might be something that you'd want to consider. So why do we use adhesives? So adhesives have several benefits in the end use that typically come up. And this is probably not an exhaustive list, but in the sign industry, aesthetics are hugely important. This is a visual medium that you guys do. Your customers come to you guys because they want a beautiful looking sign on your building, and you guys show up at work every day working to deliver that. So what adhesives allow you to do is eliminate exposed fasteners, eliminate rework, eliminate distortions and heat affected zones that might cause visual blemishes. They allow you to kind of use different mixed materials, maybe lighter gauge materials, maybe pre-finished materials. So it's all about aesthetics. If you really want the best looking signs, I mean, there used to be way more exposed fasteners. Again, talking about other industries, if you've driven down the highway for a length of time, you see the old kind of trucks that are full of rivets, hundreds and hundreds of rivets all the way through. And then you see the more modern trucks that a lot of the trucks on the road, those body panels are glued on today. And you see that kind of smooth look without those exposed rivet heads. I think the same is true in the sign industry. You'll see a lot of really, sometimes we're talking about, 10, 20, 30-foot signs that are on the side of a building where you're not getting close enough to that sign to really see exposed fasteners. But anything that's eye level, anything that's big, anything that's mission critical where it has to look good, that's where adhesives can kind of come into play and really elevate that visual brand that you're creating for your customer. Next is dissimilar materials. Compared to other types of manufacturing, that's one of the things that's unique about the sign industry, is in the sign industry, you're using so many different materials. From 1 week to the next, from one day, even in the course of one day, how many different kinds of materials are flowing through your shop, from aluminum to steel, sometimes copper, brass, every kind of plastic, acrylic, polycarbonate, composite materials, ACM, the list goes on. So you guys have to join all sorts of different materials. Welding has its place, but it also has its limitations. Welding dissimilar materials is either difficult or in some cases impossible. And mechanical fastening, might need to be avoided in certain situations, again, for those best aesthetics. Time savings is huge. If you can, there's actually a slide that kind of didn't make it to the main run, to the appendix, but there's a great visual representation. One of the other companies out there, ITW Plexus, did a really good time study of manufacturing, showing what was, in a standard, what we call conventional assembly, what kind of time sequence was used to build your typical part compared to where adhesives are part of the process. And we save time in surface prep, we save time in prep, we save time in welding, we save time in rework, we save time in post work. So there's usually significant time savings when adhesives enter the picture. I've kind of already touched on post processing. That's extremely important. Often in the sign industry, we work with pre-finished metals. You got your mirror finished stainless, your brushed aluminum, your pre-painted metals. Often you're paying a premium for those pre-finished materials. So it makes no sense at all to order expensive pre-finished materials, weld them up, and then pay somebody else to get that finish back again after you've experienced some distortion. So if we can help you guys use those pre-finished materials and use them, then that's important. Then I already mentioned the post-processing, lightweight. This kind of goes hand in hand with design, that when we make something lighter weight, we can often use that. That's also the next two things are related: lightweighting and material savings. Oftentimes people are using thicker stock metal simply because they need metal that's thick enough to weld, and to get that weld and do it appropriately. Sometimes some of this metal is too thin to weld. So by going to a lighter gauge metal, we can reduce the weight of the whole assembly. We can reduce the material cost. Again, we're in a context of tariffs of, there are 50% today steel and aluminum tariffs. A lot of US production is involved in the sign industry. As I'm talking to sign fabricators, I'm not hearing from a lot of sign fabricators that they're paying 25 or even 50% more for that aluminum. But the case remains that these materials are expensive. They're getting more expensive. They've gotten only more expensive over the last 4 or 5 years or more. And so if we can control material costs, that's important. And then really the last two, I think, actually are the most important. I think labor savings is probably the number one reason that at least speaking for Chemical Concepts, that we get called in to replace a conventional assembly method. When there's labor involved, we are in an unprecedented labor shortage. We are in an unprecedented welder shortage. It is so hard to find welders. It is so, many of you on this call, many of you on this webinar, many of you watching this recording might be welders. I have the utmost respect for welders, but it's just a fact that we have not enough of them in this country. And the ones that we do have, if you're a shop owner or a shop manager, it can be very difficult to manage your schedule if you have, X amount of welders and one person calls in sick, or one person leaves to take another position or retires, etc. So we have more people leaving the trade than we have coming in. So it's incumbent on us in the industry to, anybody can pick up a glue gun, and with a little bit of training and pointing in the right direction, can start gluing things together, and you could reserve your welding for the areas where it's most essential. So anyway, that's just kind of an overview on what does adhesives bring to the table. Now, this is a smooth transition to adhesives versus welding. So we'll never replace welding. Welding has its place in the sign shop. Going back to that survey that everybody took, many of you on this call don't have a lot of trust in welding. A lot of people on this call said, we don't use adhesives that much. Well, what are you doing? It's either welding or mechanical fastening. So I'm going to assume that there's maybe some people here that maybe would tend to err on the side of welding. So we already talked about the welder shortage. Now, when I say as strong or stronger, this is an important point because often it's kind of apples and oranges. If you were to take two identical, let's just say, just to keep it easy math, a 1 square foot square of metal, so a 1 foot by 1 foot square, you're going to put two squares like that together in a butt joint, in a lap joint, and you were to do a continuous weld and compare that to a continuous bead of adhesive, completely like for like, and try and pull both of those things apart in a machine that measures the force to separate them, that weld would probably be stronger. But often when we're replacing a weld with adhesives, we're not replacing a continuous weld. We're replacing we have to design things differently for adhesives. And when people have that lack of trust, or they have, to put it in the positive, they have that extreme trust of welding, that might come from those notions like, I'm going to design something the same way I would design it as a welded joint and expect it to perform the same way. It is a different tool. It has to be approached in a different way. We would have to design the joints differently. So you can absolutely achieve whatever results you want to achieve in a bonded joint, but it would have to be done differently. So often we can exceed the performance of welding if we compare appropriately. So using this example in this picture, you'll see two rectangles with three spot joints, with three spot welds. If you were to compare that, now compare that with an adhesive joint, same geometry, same pieces, with a continuous bead of adhesive with a 1-inch overlap. A typical strong MMA 10-to-1 acrylic adhesive might be 2,000 to 3,000 psi for aluminum to aluminum. So if you have a 1-inch wide by, let's say that's a 12-inch long piece, so you have 12 square inches of bond times 2,000 psi. Now you're getting into pretty incredible strength. And so if you were to compare that against that spot welded example, we could absolutely meet or exceed the strength of welding. And again, I don't ask you guys to take my word for it. Lots of engineering has gone on to this. A lot of major companies are involved in the production of these adhesives, in the engineering of adhesives into not just signs, but we're in aircraft, nuclear submarines. If you've ever ridden in an airplane, something I like to say all the time is you've trusted your life to adhesives. So they absolutely work. They've been proven. There's a proven track record in the sign industry. It's not even a new technology to the sign industry today. I think we've got a solid 15 to 20 years of track record, and there's signs in service today that have stood the test of time with structural adhesives. So those are some of the things that we can do there. When we talk about, I already touched on mixed materials, welding aluminum can be challenging. Welding aluminum to steel can be challenging, if not impossible, in many designs. We have protective coatings and paint. We want to eliminate that rework. Another thing we like to say with adhesives is that we can bond and seal in one step. We're always about removing steps, making things more efficient, looking at throughput, making sure that you can get your job from the beginning of the shop out the door into the hands of your customer or onto the side of the building. So if we can take an operation out, instead of having to weld and then come in with a silicone or some other sealant, we can use a liquid bonding agent that can do the mechanical assembly and seal for light and moisture in one go. So that's important. Material deformation is important with welding. As you may know, there's probably some people on this call. I'm not an expert in everything. We'll claim to be an expert in adhesives. But I'm not an expert in welding, but I do know about heat affected zones. You guys probably know about that. When you overly heat stress a piece of metal, you're reducing that ultimate capacity of that piece of metal. So when you have deformation, that creates post work and often as well a reduction in the total strength of the assembly, which again may or may not be relevant depending on the design. So moving on to aesthetics. This is a great example here, this picture, building an ATM enclosure. This is a great example of that clean look. There's no exposed fastener. Everything looks clean. This was supplied by a customer. And you can see basically everything that we've talked about. Mixed materials, no exposed fasteners, clean lines, pre-finished materials, mixed use of composites and non-composites. We got diamond plate, we got ACM, we got what appears to be polycarbonate or acrylic there. So it's really all about these results. I think that picture kind of speaks for itself, that if you really want optimal aesthetics, you probably want to look at what you can do with adhesives. And if you raise your hand, if you need help, Chemical Concepts is happy to help. Our partners are happy to help. IPS is happy to help. Lord Corporation is happy to help. All of the major, this is educational. We're not here to take a particular side of one brand versus another, but there's a bunch of reputable brands in this industry, and all of them have resources to help you guys get what you need. So we've kind of already touched on the dissimilar materials, but another great visual example, acrylic to aluminum is another combination for bonding that would be very difficult to achieve with any other means other than adhesives. There are different technologies out there, whether it's solvent cements, whether it's MMAs, whether it's silicone, whether it's one component sealants that are of high clarity. There's clear tapes that when you need that clarity, when you need that mixed materials, when you need the other thing that adhesives do that both fasteners and welds can't do that I did mention is shock absorption and impact resistance. Oftentimes, some adhesives are quite rigid. Your epoxies on the one end can be very rigid. Your MMAs, your acrylic adhesives can be somewhat rigid, all the way to a very flexible silicone or double-sided tape. Once you go to those lower modulus products, to use a technical term, they can often allow a little bit of vibration and resistance for impact, which can be important if you have signs that are, say near an interstate or near heavy road traffic or near rail or have, susceptible to, will be exposed to wind forces or anything like that that might take a beating. So anyway, that's a little bit about that why adhesives. I'm going to take a little bit of a pivot here and really talk about some of the basic chemistries. As you can see on this slide here, this is just a small snapshot of some of the common adhesives that are in the sign industry. This is not an exhaustive list by any stretch of the imagination, but these are the ones that you are often probably familiar with or maybe see the most. So in terms of broad categories, we can think of this as structural adhesives, tapes, one component, sealants, elastomers, solvent-based adhesives, and cyanoacrylates or superglues. There's many more, but this is a kind of short list. I know one of the frustrations or pain points that many shops have is, why are there so many different products? What is an MS polymer? What is an epoxy? What is an acrylic? Can't there just be one glue that sticks everything? We wish. But the reality is that there's many different types of products on the market, and having, are you going to know this stuff inside and out? Maybe not, but having some general understanding of what the different products that are out there, being able to put things in the appropriate box and understand when to use what. So first of all, let's start with structural adhesives. So the structural adhesive is a funny term, and it can basically be defined as any adhesive that can handle a considerable load, and that's typically defined as 1,000 psi. So this is, not a light-duty adhesive that's holding a sign on the wall. This has some sort of what we would call structural element to it. So there are three basic kinds of structural adhesives. This is not fixed in stone because they're working on new products all the time. There's a lot of really smart people out there, scientists, working on new novel chemicals. There are new adhesives launched all the time, but the basic families remain. So you got acrylic, epoxy, and structural urethane. The ones that you guys are probably most familiar with is structural acrylics. Just to throw some names out there that you might be familiar with, you might be familiar with Lord Signlock series, Lord Signlock 204, Lord Signlock 406, Signlock 810, IPS Weldon number 30, Weldon 31, Weldon 45, Plexus, 3M, Loctite. I mean, these are some of the major names. Adhesive systems. You see a lot of adhesive systems out there in the sign industry. Maybe some users of MP55 420. All of those products that I just listed are MMAs or acrylics, some of these are just brands. But all of those brands at least have some MMA or acrylic, and I use those terms interchangeably. So acrylic adhesives are one of the dominant structural adhesive technologies in the sign industry. They're great for bonding aluminum. They're great for bonding metals. They're great for bonding bare and unprepared metals. They can often do cross bonding, so you can bond metal to plastic. Acrylics can have a wide range of properties, from very rigid to somewhat flexible to all the way up to, some products in the market have 25, 50, or even 100% elongation and movement capability. So depending on the particular product, there's a wide range of properties. And acrylic really overtook epoxy. If you were to look backwards in time, say 20 years, epoxy was really the dominant structural adhesives in many industries. And acrylics over the last 20 years have rapidly taken market share from epoxy because of a couple of things. That minimal surface prep. Many adhesives on the market offer that you basically just solvent wipe and go. Some of the acrylics on the market can cut through surface greases and surface oils. So surface prep is something that it costs a lot of time, it costs money. So if you can get similar results with less prep, then that's something that people want to do. Epoxies can bond metal to metal, but they often need much more intense surface prep. You have to really grind, put some deep scratches, give some mechanical areas for the adhesive to flow into. Take maybe some 80 grit paper, put some deep scratches into the material. Acrylics really simplifies that. With the acrylics, you also get a different cure profile, I would say. So epoxies have what I call linear cure. So you basically at 50% of the cure time, you're 50% cured. So if your epoxy is an 8-hour cure, at about 4 hours in, you're about halfway done in terms of halfway to the ultimate strength. Many acrylics on the market, you can't speak for everybody, but many acrylics on the market really are 90% strength in the first 2 hours, which is very important for production. When do you need strength? You need it right away when things are handled in the shop. The sooner you guys get this to the next stage of production, the sooner it is for you to get it out the door. I kind of touched on epoxy in the discussion of acrylics. The distinction that I'll add for epoxies, generally speaking, epoxies are better at adhering porous materials versus non-porous materials. Acrylics are great at plastics, metals. Epoxies perform better on brick, masonry, wood. So if you have to do aluminum to wood, aluminum to brick, brick to brick, brick to wood, even foam to plastic to brick, any porous material, the epoxies are generally perform better, and those are areas where you might choose an epoxy over an acrylic. I had an application where somebody really wanted a bulletproof structural adhesive to adhere a metal sign to a brick exterior wall in the interior of a parking garage that would be exposed to the elements, and epoxy would be a great solution there. And then I won't spend as much time on two-component urethanes. They're probably used the least in the sign industry of the three. Where these come into play, they're often more flexible than either epoxies or acrylics. They're often relatively low cost, and they're good for plastic to plastic bonding. They do not adhere bare metals, but they will adhere prepared or painted metals. So painted metal to, they're also great at bonding HDU, so painted metal to HDU, plastic to HDU. Those are good urethane applications. And then there are also some optically clear urethane. There's a subset of urethanes called polyaspartics, and those include like the Weldon 55, Weldon 58, Lord 7550, Araldite 2028. Those are high clarity, non-yellowing, almost optically clear products that are great for aesthetic bonding. They will not yellow. They will not yellow in direct sun. And that's something, epoxies will yellow, acrylics will yellow. So if you just need that ultimate clarity, that's another situation where urethanes tend to shine. I'll talk about, I want to spend the most time on the acrylics and the structural adhesives, because that's where really a lot of these products are used. Probably used the most by volume. There's a lot of tapes in the industry, double-sided tapes. Many of you guys are familiar with like VHB style tapes. VHB style tapes, 3M has their VHB series. There's ChemSet VST. Oracle has a product that fits into that family. Those double-coated extruded acrylic tapes. So those tapes are very high strength. They're not nearly, a great two-component epoxy or two-component acrylic might be 2,000 to 3,000 psi. I mean, your best double-sided tapes are maybe 200 to 300 psi. I mean, 3M just came out with VHB Max, which is their best performing VHB yet, and that's not really even in the same ballpark as some of these structural products that we talked about. But the benefit there is that you get that instant grab. Now that can work for you or against you. Tapes can be very convenient. You have that instant adhesion, but it also means you have one chance. So when you're using a tape, you want to make sure you have everything lined up. Some customers use dowels or some other tool to make sure they have everything lined up perfectly before they apply that pressure, because if you get it wrong, it's going to be very difficult to undo, and you have to scrap that tape and get fresh product. So that's an important point about tapes. Then you have one component sealants, construction adhesives, silicones, MS polymers, urethanes. They all fit in that kind of sealant family. We see a lot of those products in the sign industry. A quick comment I'll make about that is that I see a lot of silicone used in the sign industry where that might not be the best tool for the job. There are hybrid and MS polymer based products that offer much higher performance. Silicone, there's a spectrum between adhesives and sealants. Silicone is really more of a sealant. It's great for waterproofing, keeping water out of assemblies. But I mean, I know I've heard many sign companies tell me and sign fabricators say, hey, I put this thing together with silicone and I could not get it apart. That's true. It does have some adhesive ability, but there are better tools for the job there. But those are probably the two products that make the most sense are silicone and MS polymers. And then there are one component urethanes, products like Sikaflex on the market. But the isocyanates is a key ingredient in one component urethanes. Those are now banned in Europe. I think it might be a matter of time until you start seeing isocyanate bans in the United States. MS Polymer provides a lot of the same advantages, but without the health and safety issues with isocyanate. And isocyanate is not a huge health concern. It does cause some sensitization, maybe some itchiness, some skin reactions, but still something that most people would rather avoid in the shop. And then lastly, I won't really talk about super glues just based on time, but for solvent cements, again, Rod's going to talk about the issues and the changes, the regulatory changes with solvent cements. You have the most well-known are resin bond, channel bond, weld-on 3, 4, and 16. Those are products that you might know that are solvent-based adhesives. And here they're called adhesives, but really it's solvent welding. You're really melting the plastic together is what you're doing there. And these are solvents that really react with the plastics, get them to kind of repolymerize it and fuse together a little bit different than the standard adhesive technology. So things you might be familiar and more on that in a little bit. And then lastly here, before I pass it to PJ to talk about best practices, let's just talk about selection. So when you're about to choose an adhesive, what are some considerations that you want to be thinking about? So first of all is materials. What are you bonding? Is it metal? Is it acrylic? Is it ACM? With the information I just provided, a lot of these manufacturers have charts that help you determine and obviously reach out to your distributor, reach out to the manufacturer. They can help you with answering these questions, but just with the time that we have allotted, those decisions are really going to be driven by what materials you're working with. Joint design, how are these things put together? What environment is it going to be in? Is it going to be interior? Is it going to be exterior? What might it be exposed to? Typically things in the sign industry are going to be one or the other, interior or exterior. I'll say process. What are you using today? Are we replacing a mechanical fastener? Are we replacing an existing adhesive? So if we're replacing an existing adhesive, typically we want to understand, what you're looking to do, how fast are you looking to move, and then again, that aesthetic piece. So I'll pass that to PJ there. I'll pause briefly. I haven't been looking at the questions. I don't know if any questions have come through. Any questions so far on the content on adhesives so far?
I didn't see any questions come through the chat yet, Andrew.
Okay.
Yeah,
All right. Well, I'll pass that to PJ for best practices. And again, any questions that you guys have, we'll make sure we'll get you an answer. If not on this session, then afterwards. Take it away.
Awesome. Thanks, Andrew. In the interest of time, I'm going to kind of breeze through this section. I want to leave enough time for Rod to go over the new formulations of their solvents and leave some time for some questions on that. I know that a lot of y'all are excited for that part. So over here, we'll just go through the best practices real quick. Andrew, if you'll move the slide for me. So we're going to go over cleaning the bond areas, prepping the adhesive, and then mating the parts in the clamps. All right, so most materials or most adhesives that you're going to use are in the sign industry on the MMA side, as Andrew mentioned, are really just going to need a simple wipe down of the materials. You're going to want to wipe off any kind of excess grease or any kind of dirt, grime that might be on the surfaces before you apply that adhesive. You can always use an alcohol wipe, a solvent wipe of some sort. We recommend the 70-90% acetone or isopropyl alcohol. There are occasions where you're going to need to use some kind of an abrasive material to rough up the surface. As Andrew mentioned, if you're using an epoxy on a metal and you're going to a concrete wall or something porous, that metal is going to need to really be roughed up for that epoxy to grab onto it. Whereas other instances where you might be using a urethane on a painted or a finished aluminum, you don't want to abrase it at all. You want to keep that nice and smooth for that urethane to really grab onto that painted surface. So depending on the application, depending on the glue that you're using, the adhesive that you're using is really going to determine what kind of steps are necessary in that cleaning area. But always make sure that you're doing that process right. That initial clean prep process is really what's going to set you up for a proper bond. When it comes to two-part adhesives in the cartridges, there's several steps that you need to take prior to utilizing these substances. So the first thing you want to do is level the plungers. So inside of each of those tubes on the two-part adhesive, there's a plunger that's forcing that material out of the tubes. You want to make sure that those plungers are level. So the easiest way to do that is to take the cap off of your cartridge before applying the tip onto the cartridge. Put the cartridge in your gun and dispense a little bit of material out of the tip of the cartridge. Make sure that both sides are dispensing a little bit of material. When you notice both sides are dispensing a little bit of material, you can go ahead and put your tip on the cartridge at that point. Then you want to make sure that you got material dispensing out of the tip. You want to go ahead and on a piece of cardboard or a piece of blank stock, go ahead and run out a bead of adhesive about the length of the tip, just to make sure that those two parts that you're working with are both dispensing properly. A lot of times you'll notice right at the beginning, like this picture in the middle is showing, that you'll have some discoloration at the very beginning as you start to dispense that material, and then it'll kind of level out to the solid color that the adhesive should be. This is kind of a general time frame of a lot of the different MMAs that we work with here in the sign industry. 8 to 10 minute open time or working time. You'll notice different times on the cartridges that you're using. You'll notice a working time, then you'll notice a handling time, and then you'll notice a full cure time. So that handling time or open time, open working time is going to be the amount of time that material is going to take to get set up. So that's the amount of time before that material is going to start to harden and actually start to cure. That's the amount of time that you've got as that material sits in the tip of the gun before it needs to be pushed out of the gun. And that's the amount of time that you have to make sure that your pieces are clamped together properly. That second time, the handling time, is going to be the time till it's ready. Those parts can be moved around and handled. With MMA adhesives, you're going to get about 90% of your cure time, your cure strength within that handling time. So most times can be around that 15 to 25 minute mark with MMAs. You've got a handling strength of about 90%, and then you'll get your full 100% strength after a 24-hour full cure. There's a lot of different methods that people will use to bond substrates together. They'll use clips, they'll use clamps, they'll use magnets. There's a lot of different ways to keep those materials together to ensure that bond line is staying stuck until the working time has approached. Andrew kind of went over this earlier, but the design is going to be your most important part whenever you're talking about switching from welds, something that you might be used to, over to adhesives. The design might be a little bit different. So you really want to design for shear and compression and avoid peel and tension. Where you're going to see failures in adhesives a lot quicker is on that peel and that tension stage. So this diagram here, these images kind of show the best practices, the do's and don'ts when designing for adhesive. And once you understand this concept, it becomes pretty self-explanatory. Bond line read through. This is something that we see often in the sign industry, especially on thin gauge metals or ACM panels. This is where you can actually see the lines of adhesive through the material or through the finished product. This is caused by thermal expansion. And it's basically the heat and the properties of that adhesive as it's curing. The temperatures that adhesive is getting to is causing an expansion and contraction of the materials that it's being applied to and causing that read through on the other side. There's a lot of adhesives out there that are designed, like I said, wouldn't say a lot, but there are several adhesives out there that are designed specifically for this application that are low exotherm. Lord has a good one in the 810. We've got one on our Ultralock line 810. And actually the Weldon 30 and 31s are pretty low temperatures at their cure rates. You typically don't see read through on those either. When it comes to powder coating, this is another question that we get sometimes. And this kind of boils down to both the read through and this powder coating slide, both boil down to making sure that you're doing your research on the front end, talking to the right people, and having the right products in place. The majority of MMA adhesives that you have in your shop are going to start to melt around that 400-degree mark. So making sure that you've got the right adhesive on it in the first place that's going to survive that powder coating temperature, or making sure that you've got other precautions in line to keep your adhesive in there. So you can use a mechanical or maybe some spot welds to make sure those parts are staying together as that adhesive softens in the powder coating process. And then once the material is cooled back down after the powder coating process, a lot of times we'll see the strength increase with those MMAs and epoxies. All right, now this is the part that I think everybody's been waiting for. I'll pass it off to Rod to go over the methylene chloride ban and the new formulation on their solvent products.
Thank you, PJ. Andrew, yeah, if you just want to advance the slide, that'd be great. I can give everybody a bit of a background into what is going on. So the EPA ban on methylene chloride and TCE that was announced in 2023 is in effect now. We have passed two key milestones or deadlines in May and August, with an additional two that I think people need to be aware of coming in October, and as Andrew alluded to earlier, in January. There is a bit of confusion around the notion of the solvent welding exemption. And while factually that is the case, solvent welding with methylene chloride is only permitted with full compliance with the Workplace Chemical Protection Program. The acronym WCPP is one thing that you'll continue to hear and see as you work through the new EPA guidelines. There actually is no grandfathering in. All existing users need to be complying with the EPA regulations immediately, with the notion of personal liability could range from fines to criminal charges depending on the severity of the violations incurred. I would highly, highly recommend that all of you go to the EPA website, www.epa.gov, or use the QR code that Andrew has just put up on the screen to download these fact sheets. They are, beyond what we're going to walk through here in the next 10 minutes, very, very good information for you to have to understand what you need to do to comply and what the potential for liability is with respect to the new EPA mandates. So first, you're going to be responsible for the exposure monitoring. And just from a scope perspective, this basically applies to all potential people that might come into your production area or your facility where methylene chloride is being used. Anybody that comes in is basically defined as an exposed worker or guest. So you're going to have to monitor the exposure that any visitor, guest, or operator basically is taking in on a daily production schedule with pretty strict accuracy requirements. Your monitoring data that you basically are going to have to compile in your recording needs to have a confidence level of 95%. Furthermore, this monitoring is going to be done on an ongoing basis. You're going to have to report back every 3 months to 5 years based on the initial results. There is an additional documentation burden of 5 years worth of record retention, and you need to notify your workers of the results. The results must be shared within 15 working days. So the scope of the exposure monitoring is the first thing you need to become very, very well aware of and implement it immediately. I'm going to move forward, Andrew. Exposure limits, the new values based on the regulation the EPA has put in place, have been dramatically reduced. The new 8-hour limit is 2 parts per million versus 25 parts per million under OSHA. The new 15-minute exposure limit is 16 parts per million versus 125 parts per million under OSHA. This represents roughly a 92% reduction in the from the previous standards. Furthermore, there is a zero tolerance policy the EPA has put in place with respect to these exposure limits. Again, something that you're going to have to take immediate care to follow. The exposure limits would be the second thing I would highly, highly recommend getting used to on the EPA documents, and something you can find using the QR code that we've provided. If you want to move forward, you are required to regulate the areas that people can work in. The physical demarcation areas must be clearly marked and must be restricted to only trained, equipped, and authorized personnel. Your signage is going to need to be multilingual in any areas where English or non-English speakers are working. And these air concentrations are going to need to be continuously monitored in these areas. Furthermore, an emergency procedure protocol is going to need to be put together, and incident response protocols are going to be mandatory moving forward. Here's the one I think that you really need to take a lot of time to understand. The respiratory protection mandate basically prohibits the use of cartridge-based respirators. You now have to use supplied air only in the form of self-contained breathing systems. These breathing systems, as well as any users, are going to have to undergo annual testing as far as fitness, and then furthermore, medical clearance for all respirators being used with any of your employees. You're going to need to set up the PPE, which does not only include respirators, but also Tyvek full body suits, as well as PVA gloves for anybody coming into the production area and your facility where methylene chloride is stored, used, and essentially there. This is for everybody. Again, going back to my scope comment, this applies to all potentially exposed personnel. The equipment costs, according to the EPA, look to range from $2,000 to $5,000 per worker setup, but you're also going to need to have additional for any guests or contractors that come into the facility, like on a sales call or to quote, or to basically help you from a consultancy perspective. Again, this is all lined out in the EPA documentation, but this is probably the one that I was the most shocked at when I looked at the overall cost per worker as far as the PPE requirements set forth with the WCPP mandate. The administrative burden is kind of interesting in that what the EPA estimates from creating a written respiratory protection plan or a written WCPP plan, you're looking at about an $8,400 setup cost. They're estimating the consultant work for the WCPP plan to range about to run about 30 hours at $200 per hour to write the actual plan, and then about 12 hours at about $200 an hour with a consultant to write your respiratory protection plan with a total setup cost of roughly $8,400. Again, these need to be taken very seriously. You're also going to be required to document why you did not choose a safer alternative when using methylene chloride. Say, for instance, the use of the methylene chloride-free versions of Weldon 3 and 16. I would take this as serious because it falls into the whole creation of the penalty structure, which looks like this. Civil penalties can range up to $25,000 per day per violation. Each requirement creates a separate penalty, and every day of noncompliance equals a new violation. There is no grace period right now. Additionally, your workers are going to be protected for reporting violations under the Whistleblower Protection Act. And what we have heard is that the EPA, as far as the auditing and any new rules, especially bans, takes customers following this very, very seriously. And as a result, acrylic and polycarbonate users are likely for targets for priority enforcement. As we kind of lay out what the penalties and the fines look like, there is also the ability for the EPA to basically shut down or stall all of your operations based on the severity of the violations that you're guilty of. So take the penalty structure very, very seriously. The bottom line looks like this. You got a total compliance cost for using methylene chloride of around $200,000 plus over a 5-year horizon, with a daily risk exposure that could be in the neighborhood of $18,000 to $25,000 plus. We're already seeing some instances in certain counties in North Carolina where OSHA has already gone in and started levying fines based on non-compliance. Personal liability is now a big problem for leadership, and we believe the future is rather uncertain with the potential for even stricter requirements to come in the years to follow. Bottom line here is you're on the line with program requirements that are going to have to identify the scope, the initial and periodic exposure monitoring, the controls you put in place, the documentation that you're required to take part in, including a justification as to why you're using methylene chloride versus a safer alternative. You're going to need to designate regulated areas and ensure that you have training protocols and systems in place to move forward if you would decide to use methylene chloride in the fabrication of your electrical signs. However, and I'll conclude with this, there is a methylene chloride-free alternative. We, having been fined and actually warned with a couple of things that we were behind on doing, decided it wasn't worth the risk or the threat So we basically took the methylene chloride out of Weldon 3 and 16. This will require no WCPP requirements to use. There is no penalty risk to use the methylene chloride versions, methylene chloride free versions of Weldon 3, 4, and 16. You will get the same world-class bonding results you're used to with the past formula, except this time it's methylene chloride free, giving you the peace of mind to move forward. I will conclude with this. Please use the QR code. Please download the documents from the EPA. Become very familiar with the requirements, with the compliance that is necessary to move forward if you decide to use methylene chloride products, solvent cements in your production. The timing is critical. We've already passed 2 deadlines. We can help you. Feel free to reach out to me, to PJ, to Andrew, the rest of Andrew's team. Go to www.assemblyadhesives.com if you want to check out the additional information that we have online with respect to methylene chloride-free alternatives. But please take this seriously. It is here now. There have been a lot of dates that have come and gone. A lot of goalposts have moved, but the EPA ban is on now, and the potential for risk, for fine, is here. But there are alternatives. Take a look at Weldon, methylene chloride-free, 0 compliance cost, no penalty risks.
Yeah, and let me just add that QR code takes you to information on that product, so feel free and scan that. And these products are available; they're on the market now. So there is another way, to avoid some of those onerous information that Rob was sharing.
Looks like we had a question come in, Andrew.
Yeah, Brad, you were muted.
Yeah, that's what I was getting ready to say. We had a question there. It says, if this new formulation works so well, why did it take regulation to affect the change?
That's a good one. Rod, you want to take that one?
Well, to be honest, methylene chloride worked. It was inexpensive, and we developed this formula 20 plus years ago, and it's been used for bonding channel letter and trim cap for years. And until the EPA decided to ban methylene chloride due to people using it as to strip paint, specifically off of bathtubs, we just never thought that we were going to need to do this because we had a product that used a very small percentage of methylene chloride. So we made the decision to actually do what was better environmentally, what was better from a health perspective, and we just think we're making a product that's easier for the customer to use without the regulatory nightmare. We wouldn't have done it if the ban were not enforced.
Yeah.
Perfect, Rod. Yeah, Andrew, looks like you have another one, a question as well. It says only a partially considered question and not with a specific application in mind. Have you started to see more discussion around design for debonding, not just for end of life, but even for rework? It's a great question too.
Yeah, that's an interesting topic, and it's I was just recently at the Adhesive and Bonding Expo. There's a convention for everything. Is something that but yeah, I frequent the Adhesive and Bonding Expo. That's a big topic of conversation in not the sign industry, but in our industry. There are some of the industry leaders in that space have come up with some debondable technologies. I wouldn't say they're widely available or mainstream yet. There's a lot of talk, of that circular economy, reduce, reuse, recycle, etc. So I think a lot of those products are coming. They're not quite on the market yet. The technology is developing. So short answer is, yeah, I think that's coming in the not too distant future. And will it make its way to the sign industry? Quite possibly. But great question.
Great. Yeah, really good question. Let's see. I don't see any others out there. Let's see. Hold on. We've got a chat. Nope, we're good there. Q&A. That looks good.
Looks like
Oh,
one more.
here's
came
one
through.
more. Yep, go ahead. It says, have the weld-on reformations been UL approved and can be used on UL approved letters?
That's a good question. I don't know the answer to that one. Rod?
Well, we have a certain number of our structural adhesives that are UL approved. Certainly, the acrylic solvents, they typically, I don't believe that we've ever really applied for UL approval for 3 and 16. I will double check, but the solvent cements a little bit different as far as UL approval. With respect to electrical signage, all of our structural adhesives do go through UL approval for the use in electrical signs.
Yeah.
that was a really good
Wasn't
question.
familiar. Yeah, I guess the old ones weren't UL approved. I hadn't considered that. I don't think I'd ever been
No,
asked.
there's a bit of a different standard as far as the use of solvent cements versus the structural adhesives, and then generally speaking, the applications and the type of signage. But UL approval has never really been demanded of 3 and 16 in the way that it has with the structural adhesives.
Okay, yeah, that's an interesting question too.
Yeah.
Yeah,
Any more? That was great.
yeah, keep them coming, guys. We're here to answer them.
Yeah. Well, I think we covered them all. So
And while we're waiting for questions too, or if any more comes in, this is a good opportunity here to just flash some contact information on the screen. I have the contact information on the screen of the 3 individuals, myself, PJ, and Rod. Feel free to reach out to any and all of us. We're here to help you. If there was some burning, if you're anything like me, I finish a conversation and as soon as I hang up the phone, I think of that other thing that I was supposed to have said. So I'm sure that's the same experience for you guys. As soon as you log off tomorrow, you're going to be in the shower thinking, oh, I forgot to ask that. Don't fear. Do not fret. We're here to help. I have this QR code here as well, which takes you to a contact form. So feel free to scan this. If you're watching the recording and you're not watching this live and you have a question, the internet never stops. So feel free to scan this, fill out the form, ask a question. I'll speak for Chemical Concepts that we're here to help you guys out. That's why we participate with the ISA. That's why we reach out to customers. We exist to serve you guys. We have a variety of free resources, so get connected, utilize them. We do lunch and learns. We come in, we do trainings. We could do a virtual session like this for your team, answer your questions live with management, with production, with whoever. We go out for site visits. We have free consultation on jobs. We've got customers that are calling us and our application engineers every day. Hey, how do I stick this to this? Or how do I bond these 2 things together? Or here's a job I'm working on. What's the right thing to use? That's why we exist. So don't be shy. We're happy to help. And hopefully this resource has been valuable. Hopefully you found this event valuable. And, we want you to feel like this is not the end, but just the beginning. So any other closing thoughts, Brad and Emily?
Brad, I'll let you
Yeah,
go and then I'll close this out.
Yeah, no, Andrew, PJ, Rod, I just wanted to thank you all. This was been an extremely informative webinar, and I can't wait to get feedback on some people that maybe we're going to watch this, watch the recording. So very, very helpful information, very action oriented. I liked everything about it. So appreciate you all, and everyone be on the lookout because the online education course is soon to follow here in about 3 or 4 weeks. Okay, Emily.
I echo what Brad said. Thank you, Andrew, Rod, PJ. Thanks for being with us today. And to all of you who attended, thank you for joining us. We will have a survey pop up as soon as this Zoom window closes. We ask that you please take a couple minutes, very short, just a couple questions, just to help us continue to improve all of our educational offerings for your needs. As a reminder, there will be an email that goes out to each of you with instructions on how to access the presentation as well as the recording. So thank you all again for joining us, and we'll see you next time.
Thank you.
Thank you.